Welcome to Math 230, and this is a hybrid section of Math 230. I was looking at my cartoon Introduction to Calculus and remembering how each of you has already climbed Mount Derivative. So you've been through first semester calculus and you've done all of this hard work. You've reached the summit, and we're going to build off of the things that you learned in first semester calculus. So here we are getting ready to climb Mount Integral. You've seen a little bit of integrals, and I do want to stay optimistic, but I think each of us can see the difference between Mount Derivative and Mount Integral, and so we do need to be realistic. This is going to be an intense semester, but you've learned so many great skills along the way, and maybe you couldn't have done this a year ago, but you can do it now because of your foundation in Calc 1. So we're going to see some exciting things, and you're going to feel great once you get to the top. We just want to be prepared. We want to make sure that we've blocked off the energy and time that are required for this second semester of calculus. Okay, so I'm about to read to you 4 pages of some quotes, all one long quote, but which I normally wouldn't do, but this is so fundamental to our semester and the background of it that I felt like it was necessary. So before Newton and Leibniz even discovered the fundamental theorem of calculus, Fermat and Descartes had discovered how to use algebra to find the maxima, minima, and tangents of curves. You've seen all that in Calc 1. What remained elusive were the areas of curves, or more precisely, the areas of regions bounded by curves. People were having a hard time figuring out this piece of the puzzle. And to be fair, no one in reality realized that these two pieces of the puzzle even went together. The area problem, classically known as the quadrature or squaring of curves, had consumed and frustrated mathematicians for 2,000 years. Many ingenious tricks had been devised to solve particular cases, from Archimedes' work on the area of the circle and the quadrature of the parabola to Fermat's solution for the area under the curve y equals x to the n. But what was lacking was a system. There was no unified way to find area under a curve. Area problems were tackled on an ad hoc basis, case by case, as if the mathematician were starting over each time. Imagine having to invent calculus each time. The same difficulty beset problems about the volumes of curved solids, we'll see these, and the lengths of curved arcs, we'll see these this semester. Indeed, Descartes thought arc lengths were beyond human comprehension. Not true. We're going to understand this semester. In his book on geometry, he wrote, "The ratio which exists between straight and curved lines is not known, and even cannot, in my judgment, be known by man." So he was pretty smart, but he was wrong about this. All these problems, areas, arc lengths, and volumes, required infinite sums of infinitesimally small pieces. In modern parlance, they involved integrals. Nobody had a surefire system for any of them. Now, the really miraculous resolution of all this mathematical frustration. This is what changed after Newton and Leibniz, so our inventors of calculus. They independently, so each of them discovered this on their own, discovered and proved a fundamental theorem. You saw this theorem at the end of Calc 1 that made such problems routine. The theorem connected areas to slopes. This is totally innovative, and thereby linked integrals to derivatives. It was astonishing. Like a twist out of a Dickens novel, two seemingly distant characters were the closest of kin. Integrals and derivatives were related by blood. And this is Stephen Strogatz, a mathematician, in his book Infinite Powers. This is what we're going to see this semester. We're going to see how derivatives actually help us find areas under curves and volumes of curved objects. These are two things that nobody really imagined would go together, but Isaac Newton and Gottfried Leibniz discovered that they actually do. So here's our typical routine for Math 230. These are the most regular types of assignments that you'll see. Initially, when you're exposed to the material, it'll be through a video and then a short quiz that you're going to take. You'll also have what are called Delta Math assignments. This is a website that gives shorter problems just to start to gain fluency on the topics that we're learning. And then some more in-depth problems through textbook assignments. These are longer, they're handwritten. They're more like the exam questions that you'll see. And then when we meet in class, we will be doing a lot of problems in groups, usually at the whiteboards. And these also will be more preparation for exam-like questions. Some of them will be solo on your own. I just want to make sure everybody's keeping up on the material, but quite a bit of teamwork here. At the end of each module, you will take an exam practice problems quiz. This is to help facilitate your studying for the midterm exam, and then you'll take a midterm exam. Here is how grades will be determined this semester. 20% of your grade will be based off assignments, quizzes, and classwork, and then the remaining 80% are on your exams. You'll have 3 midterm exams and a final exam. I will tell you, so because your grade is so heavily weighted on exams, we want to make sure that you're totally prepared for these in every possible way. You'll do that best if you give this part your best effort and don't rely too much on the help that is easily available through solutions manuals or online integral calculators. Of course, you'll have access to those, but you won't have access to them on the exams. And so you want to do this work as independently as possible so that you are prepared for the exams and the final exam where you won't have access to a lot of help. This is definitely where the heavy lifting of the learning happens, and we want to make sure that you're getting really strong as you go through these exercises. The grade distribution is pretty standard. So we definitely want to give you some resources for help all semester. I consider Math 230 one of the most difficult courses offered at the community college, and so please don't feel like you have to, slay this giant all on your own. We want to be helpful all along the way from day one. And so these are a few ideas. Be in class every time on time. There is the math tutoring lab that you definitely want to use as much as possible. It's free, it's drop in. You can either use the one on the second floor of the library, or there is an online version, and the online version uses CGCC tutors. This is where you can get questions answered. I don't want you to languish on a problem for like 8 hours. That's not a good idea and could be potentially very frustrating. On the other hand, you don't want to rely on the tutors too much. You do want to stretch your brain. You want to be able to really attempt problems. And so do all that you can on your own initially, and then definitely use the tutoring lab or the tutors to kind of nudge you in the right direction. You can also definitely always message me on Canvas. I get those messages fairly quickly and I try to answer them fairly quickly. I want to be your coach. I want to be by your side. I want to, of course, there's going to be some productive struggle, but I want to alleviate any unnecessary struggle. So I'm here for you also on your team, trying to help you along. This is the textbook that we'll be using this semester, Active Calculus, and it's found at this website. We'll begin our class in Chapter 5. So just remembering that Math 230 is a 5-credit course. It's pretty substantial, almost like taking two classes, two somewhat challenging classes. And this section is a hybrid section. We're going to see a lot of really beautiful things this year or this semester, and looking forward to working together as a team to get everybody on track to really understand and learn this material. So just a little bit about me. My math background is I did go to BYU and got an undergraduate in mathematics. And then I went to UCLA and got a master's degree in mathematics. Looking forward to a really great semester.